Good morning, my name is Ken Packwood. I'm the lead facility mechanic for the Fluke Corporation. I'm also the HVAC specialist for the Fluke Corporation. And this morning I'm on the roof of one of our production facilities here in Everett, Washington. And as you can see, it is a beautiful day in the Pacific Northwest. I don't know why people say it rains here all the time, because it's always like this. Well, anyway, let me show you some of the equipment that I work with out here. Like I said, we're on a production facility. We've got about 45 rooftop units, gas pack units, gas heating, mechanical cooling, all on the lower roof, also on the upper roof. And the area that we are at today is directly above our cafe and also a conference room. And in fact, the unit that we're going to look at today is AC 13. AC 13 provides heating and cooling for one of our for one of our conference rooms. And it's pretty important when you're in there in a meeting that you have heating and air conditioning and you're comfortable. The unit that I'm going to use today is the Fluke 116. It is a digital multimeter. It was designed for the HVAC industry. I have one. I use it all the time. I like it. I recommend it. I don't just recommend it because I work for Fluke, but I recommend it because I've been in the trades 35 years and I've always used Fluke instruments. In the last 4 years, been working here at Fluke, and I get my stuff for free. I really like that. Anyway, we're going to check a capacitor today. Pretty simple check, but it's important to have it done correctly. And so, using safe procedures and with the use of the right tools, this simple check can be done pretty quickly and pretty efficiently. I have two compressors right here. I've got an electrical cabinet here. We're going to de-energize our system and open up the electrical cabinet and just take a look in there. Anytime I open up a piece of equipment, I like to take a look at the electrical. These units sit up on a roof. They are used a lot, and I like to just go through and check all my wiring. I'm looking for brittle wiring. I'm looking for burn marks on the wiring or on the contactors. These contactors are covered, but I've looked at those last month and I'm pretty content that this unit is in pretty good shape electrically. All the connections are nice and tight, nothing that's going to vibrate off, and so I'm pretty happy with that. This is the capacitor that I'd like to take a look at. So I'm going to take my meter. It's got a nice industrial magnet on it. I can set that right there, and first thing that I need to do is remove the boot that covers the electrical connections on this capacitor, and then I'm going to remove the spade connector from one side of the capacitor. Notice I'm using insulated tools. Even though this unit is de-energized, these capacitors are designed to store energy. So first thing I want to do is I want to dissipate that stored energy. Using my insulated tool, I'm going to short across the terminals, and that just ensures that there's no potential energy there that can affect my readings. So now that I've done that, I'm going to take my 116 meter. I'm going to go to an ohm scale. And the first thing that I always do when using any meter is I take a continuity reading. The continuity reading allows me to make sure that my test leads are in good shape, they're properly inserted into my meter, and the internal circuitry of the meter is all operating correctly. And this looks good. Like I say, I do this every time I use my meter. The next thing I want to do is I want to just check this capacitor real quickly. So I'm going to go down here to the proper scale, which is a capacitor scale, and the unit is going to give me a reading in microfarads. So hooking my leads up across the spade terminals, and I can see that I have 7.67 microfarads, and that's exactly what I want. This, I don't know if you can pick it up on the camera right here, but this is rated as a 7.5 microfarad 370 VAC capacitor. I'm looking for 7.5 microfarads, and just another check here. I've got 7.66. That tells me that this capacitor is in good shape. I can replace my electrical connections on the capacitor, replace the boot connector, make sure that's on there nice and securely, and then I just close up my unit, close up the electrical, and turn this unit back on, and we'll be ready to cool that conference room and keep all those people in the meeting downstairs nice and cool on this warm summer day. All right, there we have it. I've completed my check using my 116 meter. I know my capacitor is good. I'm going to re-energize the system, and in a few seconds that fan motor is going to come back on, and people down in the conference area will be nice and cool. My name's Ken Packwood. Glad that you were able to join us today, and I'll see you next time. Bye-bye.